Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is Wi-Fi range, and it is a easy level problem. So this particular problem says that we have been given a string S which represents the in rooms in the Geekland State University hostel. So like the string, each character of the string will be representing one particular room and the total length of the string will be n, right? So S of I, when S of I is equals to 1, that means there is a Wi-Fi in the ith room, and when S of I is equal to 0, that means there is no Wi-Fi in that particular room, right? Now each Wi-Fi has a range x, right? So if there is a Wi-Fi in the ith room, then it will extend to x rooms on the left as well as x rooms on the right. So now we have to tell whether all the rooms will be covered with the Wi-Fi or not. So let us see this with some example. So let me just take the second example. So in this case, the whole hostel will be covered with the Wi-Fi, and I'm going to explain you how. So the first Wi-Fi is at position this particular position, right? Now there is no Wi-Fi, there is no Wi-Fi here, there is Wi-Fi here, and there is no Wi-Fi here. So the first Wi-Fi will cover this particular room because x is equals to 1. So when x is equals to 1, the first Wi-Fi can cover the room left to it and right to it, and since there is no room to the left, it can only cover the room to the right of it, right? So now this particular Wi-Fi, the first Wi-Fi cannot cover any other further rooms because the value of x is only 1. Now the second Wi-Fi will cover this particular room and this particular room. So you see, all the rooms have been covered with Wi-Fi. Now how can we actually solve this question? Now one way, or the brute force approach. So let us discuss this particular approach first. So the brute force approach is to just traverse the string, find all the places which have the Wi-Fi. For example, if this particular index has a Wi-Fi, so what I'll do is I'll just go to these left positions and right positions, right? For example, I am at 1 here, at 1 is at here, so I go x positions to the right and x positions to the left and mark all of them as like I can make a boolean variable or boolean vector or anything I want. I just need to store that these rooms are covered with the Wi-Fi. So let's say I mark all of them as 1, that these are also covered with Wi-Fi, right? So remember that the original string and this vector which will take care of the whether the current room has been covered with Wi-Fi are different. So this one does not, so the one here does not indicate that this Wi-Fi can also extend further, right? These two things will be different. Now when I do this for the left and the right, I just move forward in the string and just look for the next one that I have in the string. Again I do the same thing, I just move x places to the left, I move x places to the right, mark all of them as covered with the Wi-Fi. So obviously this the room with the Wi-Fi itself will also be covered with the Wi-Fi. Now when I do this, I can just traverse to this particular vector and check even if there exists a single room which has not been covered by the Wi-Fi, that means I cannot form my answer, or all the rooms cannot be covered with the Wi-Fi, right? So this is the brute force approach, and since for each of those we don't know how many ones will be present, so for each of those ones what we have to do, let's say the string S is of size n and it has n number of ones, so the total complexity will be n into twice into x. Why twice into x? Because x is the length that we have to traverse for each of those ones. So we go x spaces to the right, x spaces to the left, so that is why we are doing twice of x. Now like we can also write it as nx, right? Since n and x can be both up to 10 to the power 5 or 10 to the power 6, that means this approach is definitely not going to work. This would be an overall n square solution, and which will not work according to the constraints, right? So what do we do now? Now we can maintain some kind of a variable which will help us store the information that the current room has been covered by a Wi-Fi or not, right? And we need to do in just one pass. That means we can only traverse the whole array only once, right? So we have to do something like this. Now let us say the current room has some Wi-Fi. Let's say this is the room structure and this room has Wi-Fi, right? Now I can store a variable. Let's say we are going to call that variable current, right? And let's say the value of x is initially 2. So at this particular room, since it can go up to 2 rooms on the right, I'll mark current as -2. So let's say -2 is present here. Now that -2 represents that it can still go up to 2 rooms on the right. So when I come here, -1 will be present here. When I come here, 0 will be present here. Now it means at this particular position, it is covered by Wi-Fi, but it cannot go to any more positions on the right because 0 rooms on the right are covered by the last Wi-Fi that we have encountered. So we start incrementing this value. So 1 and then 2. Now since this value has got positive, that means there are 2 rooms on the left at this particular index. There are 2 rooms including the current index that needs to be covered by some Wi-Fi that has to be present on the right of this particular room, right? Since the maximum possible limit a Wi-Fi can reach is only 2 rooms, so as soon as it reaches 3, that means uh, no matter how many Wi-Fi appears now, that this particular room will always remain uncovered, because if I write W here and let's say there is a Wi-Fi present here, it will cover this particular room and this particular room, right? So this is some normal analogy that I'm trying to give you. But if there was a Wi-Fi here and the value never reached 3, then it would have been able to cover this particular room and this particular room. So whenever the value of current, so like the way I have implemented this is, whenever the value of current is less than equals to 0, that means the Wi-Fi that we last encountered while traversing from left to right can cover like current number of rooms. So obviously we'll have to take absolute of current, can cover current number of rooms to the right of it, right? So the idea is, whenever the value of current is less than equals to 0, that means while traversing from left to right, the last Wi-Fi we encountered can still cover absolute of current number of rooms to the right of it, to the right of the current index. So for example, if it was -1 here, that means the last Wi-Fi can still cover one room to the right of it. It is 0 here, that means it can cover no more rooms to the right of this particular room, right? Now when we start incrementing the value of current again, so whenever current is greater than 0, that means there should be a Wi-Fi present to the right of the current index such that it can cover current number of rooms, right? So whenever 1 was here, so that means we need a Wi-Fi that can cover one room. So that means if a Wi-Fi is present here, then it is well and good. When we reach this particular index and there is still no Wi-Fi, that means we need a Wi-Fi that can cover two number of rooms. Now if you again increase the value of current and there was no Wi-Fi here, let us say that there was no Wi-Fi here, right? The value is 3. So we need a Wi-Fi to the right of this particular index that can cover 3 rooms, right? So if I write W here, that means this Wi-Fi should be able to cover 3 rooms. But since the value of X is only 2, I cannot make my answer, because the maximum value any Wi-Fi can cover is 2, or the maximum rooms any Wi-Fi can cover is 3, right? So that is why I can just return my answer from this particular place, right? So this would be the solution of this particular problem. I'm going to start the current variable as 1 for the first index, right? Whenever I reach a Wi-Fi, I mark the value of current as -x. This is going to be algorithm. So whenever I reach a Wi-Fi room, I can mark the value of current as -x, and for each index, I'm going to increment it, right? So this would be the whole solution. Now let me just quickly summarize through what I just said. So the first idea to solve this problem is using brute force, in which I just traverse the string, and whenever I encounter a 1, I mark all the x places to the left and all the x places to the right as visited, or I can mark them as that these rooms can be covered with Wi-Fi. So at the end, if I traverse to my visited vector or my Wi-Fi vector, whatever I can call it, so if there is at least one room which has not been covered by the Wi-Fi, that means my answer will be no. So the total complexity of this approach would be n into x, and this is not acceptable because n and x are both very huge and they are up to 10 to the power 5 or 6, right? So this is not what we are going to do. So instead what we do is we are maintaining a current variable which is going to store the state of the current, right? So the way I have implemented is, current is going to represent the following information. Whenever current is less than or equals to 0, that means there was a Wi-Fi that we have encountered while traversing from left to right, right? So the last Wi-Fi that we encountered can still cover absolute of current number of rooms to the right of the current room. So if it was -1 here, that means it can, the last Wi-Fi that we encountered, that was this one, can still cover one room to the right of the current room, right? Now, whenever the value of current is 0, greater than 0, that means if I just place a Wi-Fi to the right of the current index, it has to cover at least current number of rooms, right? So that means if the value of current was 2 here, that means if I just place a Wi-Fi to the right of it, it has to cover 2 number of rooms, right? So if the value of current at any index becomes greater than the value of x, that means our answer will be no, because there will be no Wi-Fi that can cover greater than x number of rooms, right? So this is our whole idea. And how do we change the value of current at each index? We are just going to increment the value of current, and as soon as we encounter the position where we have a Wi-Fi, we can just reset the value of current as -x. So this is our whole approach. Now let me just show you the code. So the code is very simple and straightforward. It is just what I have explained. I initialize my current value with 0, and if I is equals to 1, that means I have to set current as -x, and I can just continue to the next iteration. Now I increment the value of current because for the first index the value of current has to be 1, right? Whenever current becomes greater than x, I can just return 0, right? So this is my whole idea. Now at the end, if current is less than equals to 0, that means I have found my answer. Otherwise I can just return false. So this is a Boolean statement that will return true if current is less than equals to 0. So this was the whole idea about the problem and problem discussion. I hope that you guys were able to understand the solution. If you guys did, then you can consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So till the next video drops, keep coding, stay safe, bye bye.